At this point, we've got a pretty good idea of how pointers work in Go. Remember, Go is a pass-by value language. So anytime we pass a value to a function, either as a receiver or as an argument, that data is copied in memory. And so the function, by default, is always going to be working on a copy of our data structure. We can address this problem and modify the actual underlying data structure through the use of pointers and memory addresses. We're now going to start talking about a little bit of a big gotcha in Go around pointers. To figure out exactly what this gotcha is and how it works, we're going to put together another little project inside of a Go playground. So I'm going to flip on over to my browser, and I'm going to navigate to play.golang.org. Now once here, we're going to add on just a little bit of code here, and trust me, it's only a couple lines, and in those couple lines, we'll get a better sense of what this big gotcha is. So let's get to it. Inside the main function, I'm going to delete the existing print statement, and then I'm going to replace it with a declaration of a new slice. So I'm going to create a variable called mySlice. I'll use the : syntax, and then declare a slice of type string. And inside of it, we'll give it the text, "Hi there, how are you?" Okay, so here's our slice. It's got 5 elements inside of it. Now I'm going to create a separate function that takes that slice and updates one of the elements inside of it. So we'll say func update slice. It will take an argument that we'll call s, short for slice, that is going to be of type slice of string. And then inside of here, let's imagine that we want to replace the first element inside the slice. So I'm going to say s at 0, which is the first element inside of there, give it the text by. So just completely replace the text inside this first element. And then underneath the original slice right here, let's call that new function. So we'll say update slice and pass in mySlice. And then immediately after that, we'll log out the value of mySlice. So we'll say fmt println mySlice, like so. Now this code snippet that we have here looks awfully similar to all the code we've been writing so far around a struct. We declare a new value, in this case a slice, previously was a struct. We then pass that value off to a function, we modify the value, and then we attempt to print out the underlying data structure after it's been passed off to the function. And so as we just saw 2 minutes ago, like in all these previous videos that we've been going through, we have been saying nonstop that when we are working with a struct or any type of value, any type of variable, and we pass it off to a function, that data structure gets copied and the copy is operated upon inside the function. We've been saying that nonstop by this point. So let's run this code right here and let's just see what happens with this log statement. Now, if the slice works the same way that the struct does, when we log out mySlice right here, we would expect the first element to still be high. So let's run this and see what happens. So when we run it, very surprisingly, we see the text by right here. So even though we did not make use of pointers, nothing like that, no memory addresses whatsoever, it appears that with a slice, when we modified it inside this function, it actually modified the original value, which is completely opposite of how our struct works. So this is the big gotcha I was talking about. This is the big thing where it's kind of like, whoa, this is not quite working the same way with a struct as with a slice. So let's take a quick break. We're going to come back in the next section and we're going to figure out exactly why this code is functioning differently with a slice than with a struct. So quick break and we'll talk about what's going on here.